Look at that liveness. Wow, what a good stream. What a good person. All right, I'm streaming this on YouTube. If y'all want to take a look at it, over here, move this over there. You should go there. You should go there. And everyone's happy. All right, I'm streaming on YouTube too, so that way I don't have to record it. YouTube can record it for me. GG or Yuri. Okay, this is book club meeting 1. So the new book we're reading is Designing Distributed Systems. So this is what, I guess we can call it the 100 Devs book club. It doesn't really matter, right? It's the whole idea is that we're here. We're doing a book club. The book that we're reading is Designing Distributed Systems. It is a free book out there that Microsoft put out there. I guess they sponsored it to be free or whatever, but it is free. You can navigate to this link and get it, and Microsoft provides it. This book talks about how you should design distributed systems, and it gives you, basically it's just an overview of a bunch of different patterns that you can use when you're designing these distributed systems, right? So don't expect us to go into extreme detail on like how to do this. It's more of like a high level overview of the patterns that you should think about when you're designing these distributed systems and what trade-offs you have to make for that pattern. Okay, so less like implementation details and more high level, does this even work? Cool. Before we begin, and this is like, I'm going to try to run this a little differently than I ran the last book club, in the sense of like the last book club I kind of just went through the material. I want this one to be more of a discussion rather than me just like shouting material at you. So I read this book already, but I'm reading it again with you all because it's only 160 something pages, right? It's really a small book. But I did give you some homework because the author here is Brendan Burns, as you can see his name here, Brendan Burns. And he was one of the core contributors, founders, whatever you want to call it, of Kubernetes. So we're going to spend today just giving a brief overview of like Kubernetes, Docker, that stuff. And then we'll just talk about chapter 1, which was a very, very short chapter, which was the introduction. Okay. So I will let the group decide. Do you want to talk about the introduction first, or do you want to talk about like containers, Docker, Kubernetes first? Yeah, chapter 1's very easy, simple. Yeah.
It was pretty much straightforward.
Let's do Docker.
It was like a brief history of like, how it came to be, how distributed systems came to be, so it's pretty nice.
Yeah. So we want to do Docker first?
The only thing is I didn't understand. Yeah.
All right, let's do Docker first.
Docker.
Docker. All right, let's do some Docker first. So I was gonna prepare something better, but we'll have to do it live because here I am. So the homework was to install Docker. So if you did that correctly, you'd have Docker installed, and you should be able to run like Docker info and see things about your Docker installation, right? So I say homework, but this is not a class. But I asked you to install Docker. I asked you to install Kubernetes via Minikube, which, let me actually start that in the background. And I asked you to read chapter 1, so that we can discuss this stuff live. So let's talk a bit about Docker, because the author of this book is Brendan Burns. He's one of the core founders or contributors or whatever to Kubernetes. I think he like created it essentially. And in this Designing Distributed Systems book, he presents examples using Kubernetes, because Kubernetes is a really good platform to use when you are designing distributed systems, because it enables those distributed systems pretty well. So all the examples in the book are going to be pretty much Kubernetes based. And when I say Kubernetes based, their examples are going to be in YAML format, because Kubernetes uses the YAML format to like define its containers and such. Cool. But let's take a step back. We all know that when you're running software, and I really, really, really want it to make this like I guess more of a live thing, and I can try to the best of my abilities. But when you're running software, the old school way to run that software was to just like download the binary or the package and then just run it, right? the same way we would run like LS, or the same way we would run like, Echo, or whatever piece of software that we're using. Nginx is a good example, which I'm not installing here, but you'd be able to run something like Nginx, which is a web server, and like run that software. That's like the traditional way, right? Go to someone's website, download the binary, run the binary in your machine, blah, blah, blah. Containers kind of take that idea one step closer, in the sense of, when you did download binaries, you went to somebody's website, you downloaded a binary, you put it on your server, and you started to run it. That's great. But now you have to manage the server, you have to manage the dependencies for that binary, you have to manage the binary itself, you have to manage the configuration. All of that stuff is kind of on your shoulders. And virtual machines were created, which allowed you to abstract an operating system on top of an operating system, right? So if you're running Windows and you want it to run Linux, you can run a virtual machine on top of your Windows machine, right? So that's how I'm actually doing that here. If you see here, I'm actually running like Windows, like in the background. The OS on my computer is Windows, but I have what's called a hypervisor here that runs another operating system inside of it. So although I have Windows on my machine, the hypervisor allows me to run another OS on top of the OS I have. And the OS that I'm choosing to run is Linux. So in here, this virtual machine is Linux. I can prove that to you by just catting out like the release, right? This is Fedora, but my main machine is Windows that I have. Cool. So that allowed you to take these binaries and run them inside of like a more isolated environment, right? So instead of managing your whole OS and your whole dependency chain, you can build virtual machines, deploy them, and life is good. Problem with that is virtual machines are pretty heavy. They're in whole other OS on top of your OS, right? That's pretty heavy, pretty resource intensive, not the greatest. We move to containers. So containers are a way to abstract further. So whereas virtual machines were an operating system on top of an operating system, and when I say operating system on top of operating system, if you think of it this way, I have Windows as my operating system, and my kernel is like the Windows kernel or whatever it's called. But I'm running a Linux virtual machine on top of this Windows machine, and now I'm running the Linux kernel instead, right? So I have like kind of both of those kernels, both those operating systems running. Containers said, you know what? Instead of having to run kernels on top of kernels, right? Popcorn all the way down, whatever you want to call it. Let's share the underlying access to the kernel and instead run isolated processes. Okay. So instead of having to run a whole new virtual machine, we have what's called a container. And what does that mean? So there's many container engines out there. That's why it's called Docker Engine. So when I had you like download Docker, you'll see that it was called Docker Engine. There's many different container engines out there that allow you to run containers. There's different container runtimes, right? Like container D run C, right? There's different container runtimes underneath, but we don't have to worry about that so much. But just know that when people say like a Docker container, they're really just meaning like a container that's run using the Docker engine. Docker, the container type is really more nuanced than just calling it a Docker container, but I digress, right? But just know there's more engines to run containers than just Docker. There's Podman, there used to be Rocket, and now there's Docker as well. But all of those are just engines to running containers. So what is a container? A container is just an isolated process that's sharing the same underlying kernel that your host is running. In this example, my host is a Fedora 38 Linux machine, so I have a Linux kernel. So since I have a Linux kernel, I can run Linux containers on this machine, and they share the same underlying kernel. So if you do Docker PS, you might see a container running or not. Since I have Minikube started, which is the Kubernetes, which we'll get into in a second, there's a container that's running for Kubernetes, but you could ignore that. But I have no other containers running on my machine. Let's say I wanted to, try out Ruby, right? I can run Docker, I can do Docker run, and I can say, give me Ruby 3, right? And give me a shell inside of Ruby 3. A Ruby 3 image exists. It's going to be pulled. And I don't know why I'm doing Ruby, but I think I'm doing this because I was literally just using this today at work and it's fresh in my head, but whatever. Give me a Ruby machine and boom, I have Ruby. I'm in the Ruby interpreter. And now congratulations, like this is Ruby, right? Puts, hello. Boom, this is Ruby. I'm trying Ruby, everyone's happy. no problem. This is running inside a container, which means it is isolated from my operating system, but it is sharing my underlying kernel of my operating system. This concept of containers is what makes this whole like distributed systems even more, I don't want to say possible, but more mainstream than it used to be. Okay. And sorry, let me just make sure that I have that window over there. Cool. If I'm done with this, if I never wanted to run Ruby again, I can just get out of here, get out of my container, and boom, I'm back on my OS, none the wiser. And I don't have Ruby here, right? Look, no Ruby here, no IRB, nothing. My underlying host was not affected by this container. It was isolated. Okay. Similarly, if I wanted to run, don't get too caught up in like the flags that I'm running here, but if I wanted to run Nginx, a web server, I can do that, right? I ran it as a container and it's running. It's literally there. And you might ask yourself like, hey, Matt, can you connect to that web server? And I'll show you. So if I go to localhost 80, where my web server would normally be running, it says, hey, you can't do anything. You can't connect. Even though I'm running in a container and I'm running Nginx, I didn't do any like connection between my host and my container to allow that web traffic to flow through to the container. Okay. So if I wanted to, I can do that. So I'm gonna do that real quick. Publish 8080. Okay. And now web traffic is flowing through my host to the Nginx container. If I were to refresh this, assuming I didn't do anything incorrect, I should be able to get this running, assuming I didn't mess anything up. So let me just double check that because I'm doing everything live. Yep. That looks good. Oh, it's not HTTPS, it's HTTP. So sorry, there you go. Boom, I forgot I had to redirect before. So you see that now this container is running, I'm connected to Nginx, everyone's happy, and every time I reload this page, you see the logs on my right-hand side running. So I'm connected through to the container. Cool. If I stop this container and I refresh my web page, it's gone, container's not running, everyone's happy. But again, I don't have Nginx on my machine. I'm running in a container. So instead of having to like ship your app's binary to some server and getting all the dependencies installed and all of that crap, you build what are called containers now, and you build all your dependencies and all your application logic into this container. You give someone that container, and as long as they have the proper container runtime, they can run your container anywhere. Okay? And that's the benefit of containers. So no longer do I have to do this dependency management hell. What version of Ruby do you have? What version of JavaScript do you have? What version of this, that? None of that. That all goes away because I just give you a container and you just run that wherever you can run containers. Any questions so far on like the evolution of like on the host deployments, VM deployments, and container deployments so far? I'm waiting for chat to catch up, so sorry. Cool. And you can do this yourself, right? You can do this. Let me see what images I have on my machine. I thought I had something here that I could have used. Yeah, I don't think I kept it. Anyway, there's containers for many different things. There's containers for Postgres. There's containers for MongoDB. There's containers for Redis. There's containers for Node.js, Ruby, Go, Python, Rust. Like there's containers for all of these things. There's containers for operating systems. So if I wanted to try out Ubuntu on my Fedora machine, I can run an Ubuntu container, and congratulations, look, now I'm in Ubuntu instead of Fedora. So it enables this rapid development that was not really possible with virtual machines. You know how hard it would be for me to spin up a virtual machine running Ubuntu and then immediately spin up another virtual machine running Fedora and then immediately spin up another virtual machine running like CentOS? With containers, it's just a one run command away and we're done and I have it. Okay, so let me close that window for now. Cool, so that's containers, isolated processes, and what I want to show you really quick, which might be a little bit above many of the audience's head here, but you see how I'm running this process here? Technically speaking, the host can see the processes that a container is running. So even though the processes are isolated, they're still running on that host and you can see like all the Nginx worker processes from my host. And if I exit this container and then I try to see those processes again, you'll notice they're all gone. The worker processes are gone. A lot of people think that like, oh, it's completely isolated, the host can't see anything. No. Containers by definition share the underlying kernel of the host you're on, which means they share the underlying process ID space, which means they share the underlying network stack, which means they share the underlying memory, CPU, all of that, right? So a lot of people think that isolation is like super like hard, but it's really not. I could have just killed this process myself from the host and killed the container, right? The isolation that happens here is not more of a physical isolation like virtual machines do, but it's more of like a logical isolation using built-in kernel features that Linux has. But okay, I'm not going to go down that path. Doesn't matter. I just wanted to show you. So what about Kubernetes, right? So we know that we can run we can run containers, and I'm trying not to say Docker containers, but it's such like it's like Kleenex. It's kind of like the de facto like term, but I know how to run containers now. I can run them using Docker. I can run them using Podman, whatever engine I want. I know how to create containers. There's a question in the chat saying, what is a VM running that a Docker container of a different OS isn't? But what is a VM running that a Docker container of a different OS? I don't really understand the question, but if you are a Docker like container, Microsoft, I think it's this one. Yeah. So you see here, I just tried to run a Microsoft Windows instance, like a Microsoft Windows container, but since my OS is Linux, I can't run that container. Right? And that makes sense if you think about it. Since my container is Linux, I can only run Linux containers on there because containers by definition share the kernel. And if there's no Windows kernel here, how could I ever run a Windows container? Does that make sense? Whereas a VM ships the entire kernel inside the virtual machine, and that's how I'm able to run my Linux machine on top of my Windows machine. Got it? And if I were to like put this out, you can see my Windows machines in the background. Okay. Another question in chat. At what point does it become destructive? Ever? Yes, it does. So even though containers are isolated in the sense of, they're given their own process like group, essentially, their own C group technically, you can mount volumes into containers and take your host files and stuff and mount them inside the container. And then if the container does something destructive with those files, the host will see it too. Okay? But if I'm running a container in a different OS, wouldn't that require a separate OS? Yes, I just said that. But I know you and Jacob are talking, so you're good. Is it because the VM includes the GUI and probably some other internals? No. So containers can have GUIs too, and you can just connect to them, right? And we're going to see that actually in a second. Cool. So you know how to run containers, you know what they are, right? You build up your apps, you put them in containers, you run them and you ship them out, and everyone's life's happy. Fantastic. But now I ask you to do this. I say, hey, run Nginx, and you're doing it. I say, hey, run 5 copies of Nginx. How do you run these 5 copies of Nginx? How do you do it? Well, you could theoretically take this command, open up another terminal, run it again, but then you'll be like, wait a minute, you have a port conflict here. That port 80 that you're trying to plumb through is already bound. Can't do this. So how do I run multiple copies of a container to get like high availability and blah, 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 blah? That's where you use something called an orchestration tool. And there are many of them out there, right? Docker Compose is actually one of them, which I don't think I have a Compose YAML that I can show you off the top of my head. I could probably get one real quick though. 1 second. Let me grab one real quick for you. I'm in my other screen so you don't see it. So I'm just grabbing a Compose file because I didn't have one prepped real quick. Compose.yaml, copy, and I'll just take the one that I did for a company. Cool. So what I can do is I'll just like demo, services, Nginx, image, Nginx latest, and we'll just do that. Boom, 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 Boom. Cool. Docker compose up. Boom. I just orchestrated my Nginx container using a Docker compose file. And if I go back to my Firefox for a second and connect to localhost, God damn it. Why DuckDuckGo? You know I didn't want to do that. Nginx is running, everyone's happy. And look, I didn't have to remember some Docker command to run it. I just defined my services in this Docker compose file and everybody was happy. Nginx is running. Oh my God, life is like, chef's kiss, right? This is great. This is what we call orchestration. So no longer do you have to remember those complex commands to run containers. You can literally run them just like this. And I think this supports a replicas attribute. If I did that, I think it might have worked. I just forget the syntax for it. But if I wanted to run multiple copies of this, I would just make more replicas. Again, I don't really use Docker Compose for purposes like this of replicas, but it's there. But this is what we call orchestration, because now we're no longer running all these complex commands. We're declaratively defining what we want our containers to look like, and then we're running an orchestration tool to make that a reality, right? And this is a step better than running Docker commands directly, because now your configuration for your containers is like codified, right? It's there in text, and it's repeatable and shareable. I can share this Docker Compose file with you all, and I actually will do that right now. And if you have Docker Compose installed, which I thought I asked you to do, but I don't know if I explicitly asked you to do that, you can drop this file and you can run Docker Compose up and you will see that do its thing. So it's declarative, right? I just shared you my file and you can do things with it. Problem is though, let's run that one more time. So I have Docker Compose up and I'm gonna do -d to like detach and run it in the background. What happens if I update this YAML file? Let's say I don't want to bind to port 80, I want to bind to port 3000. If I save this file, my container is still bound to port 80. Nothing's changed. Nothing reacted to this, right? There's no like live updating. If I wanted to fix this, I'd actually have to bring this down and bring it back up. And now my Nginx is running on port 3000, right? So you see how it's refreshed? No reactivity, nothing. So the file is like a step better, but we can do even more. Do all Docker files start with --? No, that's a YAML syntax. ---- is how you start a YAML file, but most people omit it because it's optional. So cool. We know how to create containers. We know that there's a concept called orchestration of how we can create multiple containers and do more things. And again, I'm not limited to just Nginx here. I could have ran like, Redis, right here. And I don't remember the Redis port. I think it's like 6379 or something like that. I don't remember, but whatever. All right, I could have ran Redis here in 3001. And boom, if I do that, now it's going to run Nginx and Redis. This is orchestration, right? So whenever you hear someone say container orchestration, what they're really saying is just a way to declare your containers without running all those stupid commands again and again, right? Some sort of configuration file. Great. And I don't know if that Redis container is going to work because I don't remember if that's the right port. But anyway, let's get rid of that. Let's kill them all. Everyone's got. Aside of Docker Compose, there's also other container orchestration tools that are out there. It is 6379. Wow, I'm a nerd. There are other orchestration tools that you can use on top of, or aside from Docker Compose. One very, very popular tool is called Kubernetes. And sorry it took me long to get to this point, but Kubernetes is a fantastic tool if you would want to orchestrate your containers. But it's also a very complex tool, right? So when you hear Kubernetes, sorry, I had someone that DM'd me. When you hear the term Kubernetes, like if we just went to like Kubernetes, I think it's .io, it'll be like, what is this? And it gives you a little one-liner. It's like, it's an open source system for automating deployment, scaling, management of containerized applications. Great, what does that really mean? We call it a container orchestration tool. It's really just a bunch of APIs wrapping some sort of container engine, right? So I have Kubernetes running because I'm using what's called Minikube. So if I do Minikube status, you'll see that my Kubernetes is running. if I do Minikube dashboard, I think that's the right one. I have the Kubernetes dashboard here, and I'm just gonna close this. And this is my local Kubernetes cluster running. There's obviously nothing going on with it right now, but it's running and everything's here. Now you might be asking yourself, like, what the heck does all of this shit here on the left-hand side mean? Like, really, what does this mean? Well, containers, you can run containers like, with a Docker engine command, right? You can just run Docker run, but containers have what's called images. Containers also have what's called volumes. Containers have what's called config maps. Containers have all these other things that surround containers to allow you to do even more complex things, right? Spinning up a container is nice, but sometimes you're going to want to mount volumes to it. You're going to want to give it some configuration files. You're going to want to give it some like networking config or whatever. Kubernetes kind of abstracts all of that stuff out for you and gives you these like high level, dare I say, objects. I think they call them resource definitions. I forget what they call them, CRDs. I don't remember. Off the top of my head, I have to remember the terminology. But Kubernetes extracts all of that stuff out for you. But for our perspective, let's not go too crazy with this. Let's just understand how we take our container and we move it into Kubernetes. So I'm gonna leave the UI here on the left, and I'm gonna open up a new terminal because this terminal is like proxying my dashboard so I can connect to it to my host. And what I'm gonna do here is I ran Minikube start earlier in this session. So that started my Kubernetes cluster. Now we have what's called kubectl or kubectl. I don't care how you pronounce it, but this is the CLI tool that you use to interact with Kubernetes. The smallest unit of work that you can schedule in Kubernetes is what we call a pod. Okay? A pod. What is a pod, Matt? A pod is just a group of one or more containers. Okay? If you heard what I said earlier, that there's other container engines aside from Docker, there's one called Podman. This pod terminology starts to make sense. Okay? So Kubernetes' smallest unit of work is called a pod. So if I try to see if there's any pods in my Kubernetes cluster, there's none there. Okay? Let's make one. And I think I had a Nginx YAML here. Yes. Right? Was this? Yeah, this is what I was playing with the other day. And I'm going to leave all that uncommented. And I'm going to leave, all that commented. It's fine. I was playing with this yesterday, but I didn't fully get it to the point where I wanted to demonstrate it. So now we're doing it live. I had an Nginx container created with Docker. I created that Nginx container with Docker Compose. Now let's move it into Kubernetes. So much like Docker Compose, Kubernetes uses uses YAML to define the container that you want. And if I read this top to bottom, and mind you, just look up to like this section right here, like just look at this so far. If I read this top to bottom, it kind of makes sense. I think this looks overwhelming to people that look at Kubernetes first, but I'm going to read it top to bottom. I think I'm going to break it down for you. Kubernetes operates on what are called like YAML files, right? This is called a manifest. You are defining the manifest for your containers or for your workloads, whatever workloads you're doing. I would like to use the apps v1 Kubernetes API. I want to create what's called a deployment, right? So remember how I said pods are the smallest unit of work? Deployments are the next level up, and they wrap what are called pods. Okay, so I want to create a deployment. The metadata for that deployment should be named Nginx, and it should have these labels, these key value pair labels. The specification for that deployment is here. That deployment should have one replica pod, right? There should be one replica of it. And to determine what pods are a part of my deployment, we use what's called a selector. So any pod that has this label can be a part of my deployment. When I'm launching new pods for this deployment, use this template. This metadata is what you're going to use to launch the pod with this label. And here's the specification that you're going to use to launch the container. The image name is kind of the most important, and the ports. All of this is literally just to define my Kubernetes deployment. Let's deploy this and see what it looks like. And first, I'm just going to comment this one out down here, so that way I don't, confuse anyone with other things. Cool. How do you do that? Well, kubectl apply -f, point it at a file, Boom. It has just created a deployment for me. And that deployment is going to create a pod for me. And you saw on the left-hand side of my screen, the dashboard updated, and I now have an Nginx pod running. And I didn't have to do anything, right? I just told Kubernetes to create it. It did the needful. Now I have this beautiful Nginx pod running. This pod has one container inside of it, and it's just an Nginx container. Let me make this bigger. And this is literally my pod. I can look at it. Oh my God, one container inside running. This is essentially Kubernetes, right? This pod is inside what we call a deployment. So deployments are, like, again, as I said, a little higher level abstract in Kubernetes. It allows you to collect pods together. So I have this one deployment called Nginx, and it has one replica, right? One pod. If I wanted to scale this deployment up to have multiple pods, all I'd have to do is go in here, change this replica, reapply this, and then now you'll see that, boom, 2 new pods have just started its life, and they'll become healthy, and they're all running. So no longer do I have to like fumble with different Docker commands or Docker Compose crap. I just tell the Kubernetes API, hey, scale this up or scale this down. And I didn't even have to edit the file. I could have did Kubernetes scale deployment replicas, or scale deployment Nginx replicas 1, and go back to 1. You'll see these pods disappear, and then it's back down to 1. This is super powerful because now you take the power of containers and it's wrapped in this beautiful Kubernetes like platform API, and you're able to scale your apps like almost instantly, right? If your Nginx servers are being overwhelmed or whatever's happening, you can be like, boom, scale it up instantly. Boom, it's up. I have more capacity. Hello, you want more traffic? Yes, I can serve you. Serve it. Who am I serving? And then when the night comes by and all your users go to sleep and you have no more traffic, you scale that back down and you save your costs, right? Boom, instant, gone. No more VMs, no more fumbling with containers, like commands, none of this. All through the Kubernetes API. Okay? Any questions so far on any of this stuff? Please feel free to ask away, right? This is for you. I want you all to like kind of wrap your head around this a little bit more. Is that dashboard generated by Kubernetes? Yeah, it's like the dashboard is actually a container running that exposes the dashboard. What I didn't show you was namespaces yet, but there's different namespaces. But I'll show you that in a second. But yeah, if you want to access, if you're running Minikube, which is what I asked you all to install for this book club, you could just run Minikube dashboard and it'll like launch the dashboard for you so you can see it. I'm waiting for the typing to finish, so sorry. Way over my head, but I'm following along. I have to play with it. Yeah, and I just want to give you the high level, right? I just want to introduce this to you so it's not the first time you see this. I'm not asking you all to like fully understand this today. I just want you to see it and be like, wow, I get it now. Okay, cool. So we have a container. Containers can be put into pods in Kubernetes, right? The smallest unit of work in Kubernetes, it's a pod, which contains one or more containers. And then those pods can be grouped into different things like deployments, right? Cool. But how do I connect to this Nginx box? How do I do this? I literally can't connect to this Nginx container. I don't know how to, right? I don't have the ability to connect to this Nginx machine. So how do I do it? So in addition to what we have deployments, we have what's called Kubernetes services. Okay, and I just want to show you that real quick. So the same way that I did like that port forwarding from the Docker Compose side where I did the publish or whatever, Kubernetes has what's called services, and that allows you to expose one or more pods as a single service. Think of it kind of almost like a load balancer, but not exactly, because services actually have different types. They can have like virtual IPs, they can have load balancers, whatever. And the type that I'm using here is what's called a node port. Don't worry about what that means right now. Just know that I'm exposing this service over port 8000. Cool. So I'm going to add that to my Kubernetes manifest. I'm going to apply it, and then you'll see that a service has been created, an Nginx service. This service is running, and it is serving all 3 of my pods behind a single IP address. Okay, what does that mean? So let me do minikube service -- all to get the actual endpoint for my service. So here's the endpoint for my service. I'm refreshing, right? It's working. While that's doing its thing, let me go ahead and scale my deployment down to 1 replica. You'll notice I'm scaling my deployment to 1 replica. No interruption of service, right? Nginx is still up, still up, still up. Even though the pods have went down now to 1 pod behind the service. If I scaled this up to 5, no interruption of service, right? Even though behind the scenes, the pods are moving from 1 to 5. All right, so now I have 5 pods behind my service. And if I scale this down to 0, you'll notice that the service gone, right? Look, it's hanging, we're done. There's no pods behind this service anymore. The service is done. But if I scale it back up, it will find that service again. It will find those pods again. It'll start serving them. Okay. Oh, I probably didn't pass it the right thing. But either way, if I scale it back up, this will eventually come back, and now I have Nginx. So it allows us to group those containers behind a common IP address or a load balancer. Cool. And that's all I want to show you with Kubernetes. That was literally it. Those are kind of the primitives, I guess we can call them, that this book is going to be discussing. You will see in this book pods, you will see deployments, and you will see services. You're actually going to see ingresses, but we'll cover them when we get there. Okay, sorry. Any questions on any of this stuff? Mind you, no questions are too easy or whatever. Ask anything you want. And I wanted to get a real application running behind this, like some sort of API or whatever, but I was busy today at work, so I didn't get a chance to prepare it. So sorry. Yeah, good. I hope it's too much too soon. That's the point, right? I want you all to hear these terms for the first time, because we're gonna go over it again and again and again, right? This is not oh my God, if I don't get it today, I'm falling behind. No, you're not falling behind. This is just showing you what's out there. What if you scale down from 5 pods to 1 pod? Is it possible users could lose service? Yes, it can be technically possible, but the service will drain those connections and move it over to the other pods. I'll be harassing you during office hours, no problem. Cool. Okay, go try this. Right here, I'll give you the YAML for this. Go try it. It's literally free. You have Minikube, assuming you've installed things during the homework. You have everything you need. YAML and I'll take off the request limits for you. That way you can see it. Yeah, this is perfect. Cool. Literally take that YAML file that I put in chat, save it as a file, and do kubectl apply -f nginx.yaml. I'm going to give you this command too, and go see what happens. Boom. Oh, and to find that out, you can do this. Here's how you get the actual service URL, so you can see your own Nginx. Boom. Jacob's asking, what does the 2 -- means? So, Nginx. In a Kubernetes manifest, every -- represents a new YAML document. So this is technically 2 YAML documents in 1 file, right? This is one, and this is the other. And these -- are there to separate them. That's literally it. This is a very common pattern in Kubernetes manifests. I thought Docker Compose files require versioning. Nope, not anymore. The Compose spec changed. You don't need it. And yeah, the Compose spec is always changing. It's weird. So you don't need to version it anymore. Cool. Okay. That's all I want to show you here. Let me actually, if you want to delete this stuff, you just do kubectl delete. Boom. The pods will go away. The service will go away. Look, no more pods. No more Nginx service. Everyone's done. And then if I wanted to get rid of my Minikube cluster, I can do Minikube delete. boom, my Minikube cluster is going down, my whole Kubernetes is being destroyed, and it's gone. And now all of that stuff that I just did leaves no trace on my machine. Congratulations. I literally just spun up Kubernetes, ran containers against it, checked something out, and destroyed it all. And my machine is still just as clean as it was when we started. Cool. All right, are there other ways to run Kubernetes? Yeah, there's multiple ways to run Kubernetes. Minikube is just one of the most popular one. But if you want to run Kubernetes locally, there's also another one called Kind. Kind is a really nice one. I'll just put these links in here so that y'all have them. Kind. There's also K3S. And then there's also what we just did today, which is Minikube. And I'll put that in chat too. Pick your poison. Minikube's nice because it has, I guess, the most community support. It's not like the best, but it's really nice. Kind is what people use for Kubernetes testing. Like the Kubernetes maintainers use Kind to test Kubernetes itself. And then K3S I actually have never used. I think it's just supposed to be just lightweight, but I never use this one. And then if you go further, there's like Rancher, Rancher Kubernetes or whatever. There's other ones. But there's like a million into Kubernetes things that you can run. Who are the competitors to Kubernetes? Any container orchestration platform. So probably HashiCorp Nomad. HashiCorp Nomad, I would say, is probably a competitor. Rail OpenShift is not a competitor, but it runs on top of Kubernetes. So it's like Red Hat's version of Kubernetes. So there's a couple of them out there. Cool. Okay. Sorry. I know that was a little long. I know that was a little much, but I just wanted you all to get the terms in your head. Like I kind of just want to prime the pump a little bit and give you like some terms. So that way, as we talk about these things in the book, you're not like, oh, this is the first time I'm hearing it. That's all I wanted. Cool. If there are no questions, I will move on to discussing the first chapter of the book. If you're using Docker Desktop on Windows or Mac, it has Kubernetes cluster by default that you can use. Yeah, I believe it does. I don't remember because I haven't ran them in such a long time. But yeah. Yeah, this is actually really relevant about the common terminology chapter. Cool. So where did I put the book? Back here. So let's talk about chapter 1. Again, if you still have Kubernetes or Docker or whatever questions, like ask them away. Don't feel like your time for questions has ended. But I really hope you like try that stuff yourself. Like the whole point, the only way you're going to learn any of this stuff is by actually typing it out. So if you have Docker installed, go run a Docker container. If you have Kubernetes and Minikube installed, go run the YAML file I just gave you. Like just try it, right? You can always delete it if you screw something up. So don't feel afraid to try it, or else you're not gonna learn. Cool. All right, let's talk about chapter 1, which was just the introduction of this book. It's what, 5 pages? It's literally nothing. It's just 5 or 6 pages of this chapter. Does anyone have anything they want to talk about from these chapters? Or this chapter. I say these chapters, but it's only one. And you can unmute yourself if you want. You don't have to like chat it in text.
Hmm. I'm trying to remember. Let me say that revision.
Yeah, no problem. I mean, there was a couple of like high level sections here. There was like a brief history of software or of systems development or whatever. Talked about like algorithmic programming, object-oriented programming, open source software. And then there was like the value of some patterns. So then he talked about standing on shoulders of giants, shared language, and shared components. These are pretty much all he discussed in the first introduction chapter.
It was something. Give me a second. I'll look for it.
Yeah, no worries. Anyone else have anything to share about anything they read in the first chapter? Or did you have any issues installing Docker or Kubernetes that you wanted to talk about? Cool. While Omi figures out what he was asking, just to give a brief thing. So the author covers like a brief history of like patterns that were developed in the software industry, and he talks about like way back in the day, we had this like algorithmic programming where we pretty much just did like wrote a bunch of instructions and told the computer to do some stuff, and that was fantastic because it allowed us to be faster with certain things. But we quickly realized that that was not going to scale to like the modern problems of the modern software era. Um, so we moved in to what we call the object-oriented programming, right? Languages like Java became really popular because it swapped out like that procedural programming languages, and it gave you this object-orientedness where you created like objects and behavior and blah blah blah, and that stayed for a while, right? Object orientedness stayed for a while, and it's still here today. Um, many,
You kind
many,
of answered my question.
yeah,
Sorry, cutting you off.
yeah, no problem. This is a discussion. So all that object orientedness is still here with us today. There's been 5 million books written on object oriented programming. Go read any of them you want. Design patterns, elements of reusable software, or whatever. This one is like the book. It's pretty good. I actually read that a while back. Not a bad book, but maybe a little dated now, but who knows? It's hard to tell with this stuff sometimes. But as we move to object-oriented programming, open source software started becoming a really big thing, and a lot of the best software actually came out of being open source, right? So that was a big pattern that the author wanted to discuss. Does anyone have anything to share about like, do you like object-oriented programming? Do you like open source software? Did you have good experiences with them? Anyone want to say anything about any of those things? I love OOP and OSS. Yes.
You love open source software.
Cool. All right. I'll move on to the next thing. Then the author discusses like the value of patterns, practices, and concepts. And he basically says like, listen, no software is going to be able to, or no programmer or no software is going to be able to like do everything from scratch, right? We're literally all standing on the shoulders of giants here. We don't build unique new systems and solutions every day. We enhance or extend existing solutions, right? None of us are going designing our own physical CPU. We're not creating the wires for our computers anymore. We're not building programming languages to run things. We're standing on the shoulders of the giants that actually did that, right? Somebody created binary, somebody created assembly, somebody created C, somebody created like JavaScript, somebody created like all that stuff. And we're standing on those shoulders of giants. And we're just extending it, right? We're creating more layers of abstractions based on what has been solved in the past. And sometimes we're revisiting things that have been introduced in the past and we're like giving them a new light. A lot of people think that containers are something that's like new, that just came out in the last 5 years. They're not. The concept of containers has been around since what, like the 70s in what we call, I think BSD jails were probably one of the first containerization kind of technologies. Maybe it was jails, or maybe it was C groups, or not C groups, chrooting. But either way, the concept of containerization has not been like, it's not a relatively new thing. It's been around for a long time. So go look at some of these things like chroots. This was kind of like one of the introductory ideas of containerization. And you'll see that this was 44 years ago to this day. Or not to this day, but like, you know, as of now. So a lot of these things aren't new. We're just standing on the shoulders of giants in that sense. So the author really wanted to make us understand that. And that's a pattern that we'll use throughout the book. I think this this section here, a shared language for discussing our practice, I think this is probably the best like section in this introductory chapter. And he says that as we're discussing distributed systems, or as we're talking to other engineers about our systems or about the problems that we have, we need to make sure that our vocabulary is aligned. And you've kind of seen that when I was talking about Docker. And I'm trying not to say Docker containers. I'm trying to say containers. And I'm not trying to say I'm trying to use the word Docker engine, because it's not just Docker that can run containers. There's other engines. So I'm trying to keep my vocabulary correct so that when we're talking about these systems, we can talk about them correctly, right? And the example that he gives is like, he might call something a foo, but you call it a bar, and you spend all day arguing about it just to realize that we're both talking about the same thing. So our vocabulary when speaking about these systems are very important. And you'll also, if you work with me, or if you talk about things with me, I often ask people to be very specific, almost hyper specific, just because the vocabulary matters, and you can lose people if you're not like hyper specific on things, right? So that's why I wanted to introduce you some of the Kubernetes terminologies, like the pods and the deployments and stuff, so you can have that vocabulary in your head and understand that a pod is just nothing more than a group of one or more containers. Cool. When we read chapters 1 and 2, you'll see what's called a sidecar container be mentioned. And that's a very overloaded term. So we need to define what that means. And we'll define what that means when we read about it. And then the last part of this chapter is just having shared components so that we can reuse things easily. We don't have to create every part of our applications from scratch, right? If you are most of us here are probably familiar with JavaScript. If I asked you to implement a sorting function, could you do that? No, you're just going to use freaking .sort, right? You're just going to call .sort. If I asked you to do floor division or ceiling or whatever, can you do that? No, you're just going to call math.floor, math.ceil, right? You're just going to do that. And these are those shared components that we're able to reuse to make our lives simpler and to allow us to focus on the problems at hand, right? You're never probably going to have to write drivers for your printer or build a distributed database from scratch or make an operating system from scratch. Those are already solved problems. They're done. You're going to be building on top of them. You can reuse those components, right? You're never really going to have to implement HTTP or TCP or UDP from scratch. Those are already solved problems. You could probably just spin up Express.js, and now you have handlers for your HTTP routes. So these shared components that allow us to reuse code is very important, and it's a big pattern when developing distributed systems. If you can identify the shared components in your system, you can make a better distributed system that can be, that component can be reused across your system. Cool. And that's pretty much it for today. Any general questions or anything that anyone wants to talk about in this chapter at all? Let me see the books. This one is... How many pages are these? Why does it not give me page numbers? Where's my page numbers? Page 11. Yeah, okay, so I figured. Cool. So when I read this book, we did two chapters a week, and it really wasn't bad because, again, this book is only 150 pages, right? It's not big at all. So I believe we're just going to do the same thing. We will run 2 chapters at a time. So next Thursday, have chapters 2 and 3 read. So we're going to dive into part 1 of the book, which is called single node patterns. So these are just patterns that you can use in your software when your software is running on a single machine or a single node, right? We call it usually a single node. So we'll read about chapters 2 and 3, and we'll cover what's called the sidecar pattern, and we'll cover what's called the ambassador pattern. So cool. If there are no questions, then I believe we are all set. So I'll stay around for a couple minutes to see if there's any questions.
Thank you so much.
Yeah, no problem. I'm trying to keep it within the hour, so that's kind of why went a little faster. I don't even know what time it is anymore. Oh yeah, we're right at the hour. Perfect. And I recorded this. Oh, I streamed it on YouTube, and they saved the recording, so I'll just like, make it available to you. Cool. I will wait here for another couple minutes, answer any questions. I'll stop sharing. That way, yes, stop streaming. Perfect. You rock. Thank you, Pseudo. Yeah, you're welcome. I'm going to try to like prepare some more examples as we cover the books, but man, I got so busy I wasn't able to do it today. I felt bad. So homework is run Docker and Kubernetes with the code you sent and read chapters 2 and 3. Pretty much, yeah. I mean, like, I'm not going to give you any hard like homework or things to do for Docker and Kubernetes. That's up to you if you want to play with it. I just want you all to be familiar with it, right? You shouldn't be afraid to run containers, and you shouldn't be afraid to spin up Kubernetes with Minikube and like run a basic deployment. And we could spend more time talking about that as you all have questions. What's the terminology? A Docker file and Kubernetes manifest. So technically speaking, a Docker file isn't anything like meaningful in that sense. A Docker file is just a file that describes how to build a container, right? A Docker container image. That's not the only way to build container images, nor is it the only way to build Docker container images, but that's just one way. Kubernetes manifest is just the YAML that you saw that tells Kubernetes what to do. That's it. And we call that a manifest. Those manifests can contain different things. It can contain a deployment, a pod, an ingress, any of those top level Kubernetes objects. It can contain those and describe them. If you really like want to nerd out about containers a little bit, there's what's called the OCI, the Open Container Initiative. Here you go. And the OCI defines the format of containers. Docker Engine knows how to run OCI compliant container images. It also knows how to run Docker compliant container images. Same thing with Podman. Podman knows how to run OCI compliant container images, blah, 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 blah. Think of it like the ECMAScript almost, right? It's the spec for containers. Like OpenAPI, kind of in a sense, right? Kind of. It's just a format for how the containers should be built and how they get run and all that stuff. A very big project at the time was like CoreOS and Rocket, and they were trying to like do a lot of open container projects, but they were bought? I don't know what happened to them. Oh yeah, Fedora took them over, I think. Sorry, yeah, we were just discussing chapter 1, not part 1, because part 1 is 3 chapters. So sorry about that. We're going chapter by chapter, not part by part. But yeah, next week we'll talk about sidecars and ambassadors, which are really fun. Missed the second half because of work, but thank you. Yeah, you're welcome. No problem. I was literally working right up until I started the stream because I was trying to figure out a bug. But no problem at all. All right, last call for any questions. Anyone have anything they want to talk about or say before I end the stream? That way I can get the recording for it. I like the little no emoji. More generally, how can we demonstrate the knowledge gained from this book for employability? Just spinning up containers and putting it in the skills section of a resume. Knowing the concepts, right? Knowing how to design this, because this book is more on the system design side of the house rather than the technical, like, ability side of the house. So it's really about understanding those system design patterns, right? Because there's going to be times where you can't modify the source code that you're deploying, but you need to be able to, I don't know, enable TLS on that server. So you might have to spin up a sidecar to do that. Or there are going to be times where the API that you're deploying is static and cannot change, but the data that you're trying to work with for another API is completely different. So you have to kind of do a translation. So then you do like an adapter pattern, right? I know that's not the next section, but adapters are in here as well. Knowing these patterns is what helps you. Knowing that, like, there's other ways that I can solve the same problem and they all have trade-offs. That's really what it's about. It's about the design aspect, not about the, like, oh, look at me, I can spin up a container. It's more just the patterns, right? Knowing why it's important to have caching or why it's important to have load balancing. All of that stuff is what you'll learn here. Yeah, and mind you, again, I really want to stress that the book is only 150 pages, right? We're not going to get into solving all the world's distributed system problems just by reading this book. This is meant to introduce the patterns so that when you go to work or that when you have a problem, you can be like, oh, I remember reading like that concept. It was the adapter pattern. Let me go look more about the adapter pattern, right? And you can start seeing where those patterns fit into your work and your machines and your programs. Cool. All right. I'm going to call it. Y'all are great. Thank you for joining. Next week will definitely just be more discussion based, which is nice. So sorry for fire hosing you all with the Kubernetes and Docker. I really hope that you all like play around with it, break it, have fun, ask questions. So don't wait until you get a job to start using these tools, right? So learn the vocabulary, use them first. Cool. All right. I'll see you all next Thursday at 8 o'clock. You're the best.